Hello everyone, we're excited to bring you this webinar on ETAP solutions for data centers and critical facilities. Data centers can be thought of as the brains of the internet. Their role is to process, store, and communicate the data behind the myriad information services we rely upon every day, whether it be streaming video, email, social media, online collaboration, or simply scientific computing. Data centers utilize different IT devices to provide these services, all of which are powered by electricity. The electricity used by these IT devices is ultimately converted into heat, which must be removed from the data center by cooling equipment that also runs on electricity. On average, the servers and cooling systems account for the greatest share of direct electricity use in data centers, followed by storage drives and network devices. Some of the world's largest data centers can each contain many tens of thousands of IT devices and require more than 100 megawatts of power capacity. That is enough to power around 80,000 US households. So let's get started and learn about digital continuity in design and operations that ETAP offers for data centers and mission critical facilities. So let's take a look at smart data center solutions from design all the way to operation side. Very quickly, starting with the multidimensional digital twin platform, it allows us to build the data revisions, configurations, as well as the graphical visualization within a data center single line diagram. To illustrate the multidimensional database, very quickly we can take an example here, which is the ETAP data center that we just built just for today's session. And in this particular single line diagram, we have two utility incomers going to multiple switch gears that have the UPS housed within them. You can double click on the composite network and see the details inside, along with the HVAC units. And then we have PDUs where the servers are essentially connected through multiple racks, and then some critical loads that have dual power supply, fully redundant at all times, getting supply from the switchboard A or switchboard B, depending upon which one's available. And this particular system, we can easily make a copy of the one line diagram. And then what that allows us to do is enable one diagram to run in load flow mode, while we can have another diagram running in a completely different load flow mode. And here we can set up a case where we're running the utility in a completely islanded manner. At least one of the utilities is fully islanded. And then we can see what happens in terms of the flow from the diesel generators here versus the power flow from the utility over here, and then compare these two cases at the same time. So having different configurations and different presentations combined together allow us to create one unique scenario. And then we can combine that with multiple revisions where we can simply see the effect of perhaps making one change in the electrical system. Could be an expansion such that we are adding a brand new renewable energy source in this particular network. So we can go ahead and add our PV system, go ahead and select the PV panel from the library. And then once we select the PV panel from the library, we can set up the number of panels in series, the number of panel in parallel, and then also go ahead and define the inverter configuration. In this case, the inverter would be set up to be about 50 kilowatt with about 400 volts. And we can continue on with our calculation. So if you go ahead and run load flow, in this case, we can see that we have 38 amps coming from this panel. However, this is my base or as-built system. So in this particular network, I can simply set the state to be future. That allows me to then set this component out of service. And then when we get into a future situation, such as the following year or a different point in time, we can say that this is actually new and it's in service, and we can now see the flow in the future state or future revision, or we can go back to our base case and see the power flow in that case, which remains unaffected. The ETAP Unified Digital Twin, in summary, allows us to import data through data exchange methods, collaborate and share data through cloud NetPM as well as the mobile app, generate deliverables, perform various analytics, connect with real-time data, and gives you various solutions for design as well as operations. If you look at the data exchange solutions very quickly, especially import from AutoCAD, you can quickly go to ETAP, choose the AutoCAD file of your choice, type in a command dwg to ETAP. ETAP automatically discovers AutoCAD, identifies the blocks, and then based on the mapping, you can begin importing the single line diagram directly into ETAP and get the one line diagram as best as possible from AutoCAD directly to ETAP without actually having to rebuild the one line diagram again. So this streamlines your work and enhances productivity. You can also interface ETAP with Revit and validate the BIM design along with ETAP. So ETAP then connects automatically to Revit, discovers it. Once it discovers the Revit files, it essentially creates a mapping file for you that allows you to map one attribute of ETAP to another attribute. You can run studies within ETAP, generate the load flow short circuit results, and then export those results back into Revit so that you can have a consolidated deliverable of the 2D, 3D, as well as the power system analysis studies for the data center design. And finally, if you're using any legacy software, ETAP is the industry standard for data center design and operations. And there are many reasons why you would switch over to ETAP and start using ETAP, but predominantly you would avoid all the hidden costs associated with having legacy software where you're not getting adequate maintenance and support, where compliances are lacking, there is security concerns, inadequate analysis modules resulting in lost opportunities, and then the software tool that you're using doesn't have an upgrade path, not allowing you to have that agility and efficiency that you need as a design firm or an end user. Now that we know what the solution contains, let's take a look at what the journey looks like for this multidimensional model. The model itself, as we saw, includes presentations, configurations, data revisions, and also can include time series data. That model is then shared with many users or colleagues across the world to shorten the project delivery time, increase the design quality by engaging the subject matter experts from various offices, and improves productivity and helps you optimize the project resources. ETAP has a user-friendly interface that allows us to quickly drag, drop, and build the single line diagram as we saw earlier. And then you can also, for brownfield sites, go out to the field, collect the data inside the ETAP app that allows you to leverage the single line diagram directly within the app itself, modify the data, and synchronize that back with the ETAP on your desktop, allowing you to save time and get the right data at the design stage, very early design stage, especially when you're doing a brownfield system expansion. And that ETAP app is available in iOS, Windows, as well as Android flavors. You can also leverage ETAP auto layout, especially if you're importing data from Excel or other legacy software where the layout is not great but can be improved dramatically by the ETAP auto build rulebooks. And you can also leverage load allocation for model validation purposes, where you can bring in data recorded out in the field, play it back through the model, and then compare the metered value versus the load flow value and have some sense of model validation done, especially for brownfield sites. And you can do this for LV, MV, as well as HV networks in a data center across AC, DC, as well as unbalanced systems. Thank you very much for joining us for this webinar, and we look forward to seeing you in our upcoming webinars, and have a wonderful day or evening wherever you may be.